Okay, so when we're talking about transformations, remember what transformations really mean. Okay, you don't have to write this down, but I'm just gonna show you visually. This is what x squared looks like. Here's x squared. When I say transformations, I want you to think, okay, well, how are we like manipulating this graph to make it look differently? Like I can move it over here to the right. I can move it, like I can reflect it down. That's what a transformation is, but that's our original graph. And when you think transformation, just saying, what are we doing to the graph to now make it this new function? That's all it's asking you. Okay, so that was just for you. You didn't have to draw that in or anything. Okay, it says, given the list of transformation on the parent function, write the equation of g of x. So now we're going to do the reverse of what we did yesterday. So instead of telling me the transformations, you're going to write the functions, which could get a little tricky, but we can take our time. Always use that, what we gave on the top in the past 2 days, as a reference. So I'm going to write it out for you on the top. F of x equals plus or minus, and I would write this too just for yourself. And then that a value, which means stretch or compress. So I'm kind of going to walk you through it, stretch or compress. And then this is your vertex form. X minus your h value. That's the x value of a vertex, and that tells you if you're moving left or right. And then you have your plus and your k value. So that's going to tell you if you're moving up or down. So the a value tells you if you're stretching, you're getting tall and skinny, or you're compressing. Hold on one second. This h value tells you if you're moving left or right, and the k value means if you're moving up or down. What's up?
Is that plus or minus?
Plus minus, yeah, plus or minus. Okay, the reason why it's plus or minus, because if it's positive, you're concave up. If it's negative, you're concave down. Okay, so every piece of this formula tells you something about the graph. Okay, so if I translate 5 units to the left, and I stretch by a factor of 2, we just kind of have to figure out where it goes. Remember, stretching by a factor of 2 is going to go right where that a value is, because a value is the compressed or the stretching. So I'm going to kind of highlight here. That a value all the way out in front, so that's going to be my 2. So a equals 2. Kind of write out for notes. You might not need this in the future. You might not need to write a equals 2. You could probably just do it. But right now, let's just write it out for the sake of notes. Left 5. If I'm moving left or right, am I going to be the a value, the h value, or the k value? Very good, the h. So I'm going to use this green to represent the h. Okay, so I have h equals, now here's a good question. If I'm on the coordinate plane, hold on, let me think of you. If I'm on the coordinate plane and I move to the left, am I going positive or to the negative numbers? Negative numbers. So my h value is -5. And this is about to prove to you what you guys were all confused about probably yesterday and the day before. Where you're like, well, if it's positive, why is it not moving right? So this is going to kind of prove it to you in a second here. So those are the only 2 things that are happening. So let's go ahead and write it out. F of x, you always have to have x in here, always. That black x, it always has to be in here. So if I'm stretching by 2, I'm going to go ahead and plug in that 2 in for the a value, because that's what you guys, or we talked about. The a value is 2. Okay, I'm going to go ahead and copy down my formula, x minus h. Now here's the thing. If I put in a -5 into where it's already negative, what happens? It makes it, yeah, very good. It makes it positive. If I plug in a -5, it's going to make it a +5 in green. That's why yesterday when everyone was like, oh, well, if it's positive, it's going to go right. Well, maybe not this class, but in the past, people were like, why is it going right? That's why, because it's originally a negative number. So if I put in a negative, it's going to go ahead and go to the left. Put down your squared. We're not moving left or up or down anything, so we're done. So taking it piece by piece and trying to figure out the graph, the function based off of it. And if you look, this looks like it's stretching by 2, and it looks like it's moving left. Sorry. Still getting over a cold. Welcome back. Okay, we are in the notes now. So now we're doing it again. Translated right 2 and down 4. Right 2. Is that going to be our A, our H, or our K? They're the only 3 options. A, H, or K. Which one's going to be translated right? A, H, or K? Which one do you think? which one tells me I'm going to be moving right? This one, or that one? H, very good. So I'm going to do it the same color. Translated right to, so that's going to be our H value. Right to is just going to be positive. And then down 4, A, H, or K? Which one tells me down? K, very good. And I know it's super tedious and just like, but you're going to get better at it. So the K value in purple is going to tell me that I'm going to be moving down. Now, if I'm moving down, is that a positive or a negative number? Very good, a negative. So those are the only two things that we're doing. I'm going right to, which is represented by the H, and down 4. Again, it's a little tedious and a little bit weird at first, but you'll get better at it. Okay, so I'm just going to write it out. F of x. We don't have an A value, and we're not reflecting, so we're just going to leave it. But I do have an H value. It's 2. And if you look, I'm just plugging in 2 in green. It's originally negative, and that's why when we have a negative, we move to the right. I think some people were getting confused by that the other day. Then down 4, and we're done. So really, you're just trying to figure out how you would write that. I'm going right to, down 4. And that is the case in this situation. Questions? Okay, let's talk about this next one. Reflected over the x-axis. If I reflect over the x-axis, I must put a negative all the way out in front, which really means I'm just putting a negative wherever the A value is. So that A value is just going to have a negative number. So I'm just going to put A equals a negative, because really, I'm not going to put a number there yet because we're not stretching or anything. Okay? So, but translated 7 units up. Is that going to be my H value or my K value if I'm moving up? Very good, K. So translated 7 units up. That's my K value. You get used to it after a while. The number at the very end, the K value, is going to be up or down. Yes. A negative number. It's just negative. Yep. We don't have like a 2 or a 3 because we didn't stretch or compress anything. Okay, left 6. That's going to be my H value. So I'm going to have H equals a negative 6 because I'm moving left. And we just plug it in. I want to take a second and see if you can plug in what we just wrote. So yeah, we just did all the work, but see if you can now plug it back in to the formula that we wrote up here. Take a second and see if you can do that. See if it's kind of clicking at all or if you still need some help. So again, go in order. Did we have a f of x equals a? Again, plug in what we know already. Take a second and see how you... If you need to work with someone, you can. Yeah, it's a little weird and it takes a little bit of time, but you'll get better at it as time goes. The more you get familiar with transformations, the better. This is day 3 of transformations, kind of working with that formula. Tomorrow we're going to work with it more. Today we're going to work with it a little bit more too. This is the only new thing that we're learning. The rest is going to be review from last week, so I thought that we might need a little bit of review. So let's talk about it. I have mine set up here because that's what the formula says. It's all set up. It's ready to go. I'm going to take my H value of negative 6 and put it in. But when I put it in, it changes it to positive 6. So you can see I'm kind of just replacing the H value with the 6. And I would take that 7, and I'm going to replace it with the K right there, and we're done. Okay, this is a really weird topic, being able to make your own function based off of the words that's given to you. This next one's kind of tough. I'm just going to cross it out because I don't really like it, to be honest with you. So just go ahead and cross off number 4. If you don't have your graphing calculator or a graphing calculator, make sure you go and grab yours because we're about to work with it now. And I want to make sure that you understand how to use your graphing calculator or the one that we give you. So make sure you go ahead and get that. Desmos is if you need it for homework, yeah. We're not going to use Desmos in class because on the like SAT and stuff, you can't use Desmos. So that, You can on the SAT, yep. But if you ever need one on the SAT, you just got it's first come, first serve. You can borrow them from me. Okay, it says, given the function, describe the transformation, so that's the first step, and then graph it. When it says graph it accurately, that means that don't just sketch it. I want you to actually go in your graphing calculator and get some points. Okay, so the transformations. How many transformations do I have for 5? How many times do we transform? Good, I see it back there. There's 2 times, 1 and 2. So there are 2 times that we transform, and here's why. If you look, after I highlight, x squared is the only thing that's left, and that's our parent function. So that -3 inside the parentheses, it always represents left or right if you're inside the parentheses. So which one? Am I moving left or right if I'm a -3? I heard it. Right. I hate that bell. I say it all the time. Right 3. Okay, what about this +1 all the way on the outside? That always represents up or down. Which one is it? Yeah, up 1. Good. Okay, and that helps you with your vertex. That basically just told you what your vertex is. By saying right 3, up 1, that's your vertex. Or just knowing yesterday when we talked about it, this is your h value and that's your k value. That's your vertex, which is just 3, 1. Again, saying right 3, up 1 is 3, 1. That's your vertex. Or just looking at this function is going to help you. Or if you type it in your graphing calculator, you could probably just find your vertex if you didn't know that. Speaking of that, this is where we want to get out our graphing calculator. And if you don't remember how to do it, it's a good time to pay attention because I want to work with you on it. Whenever you're looking for a graph, you want to make sure that you go to y equals, which is in the left corner, and then press clear because I'm sure that there's another function in there. And all we're going to do is we're going to type in this graph or this function. So here we go, left to right, parentheses, hold on, x, which is right next to the green alpha.
It's like XTN, I guess.
Hold on, I will help you in just a second. I'm going to walk you through it first. Okay, and then we have -3, close it up, squared, +1. I know it's kind of boring to just kind of like learn about using this technology, but it's only going to help you in the long run. If you press graph, you can just kind of see what it looks like just so that you visually know what it looks like. And look, your vertex is right that you said earlier. 3, 1, 2, 3, up 1. You got it right. Or if you didn't know how to do it, you could have just typed it in the calculator and also looked at the graph and figured it out. Who remembers how to get the table based off this calculator? Like, what do I have to press?
Graph.
Just graph. Well, I don't have to press graph. I have to press something else. Yeah, the blue second button and then graph. And look at that. There's your beautiful table. You can get all the points in the world. Okay, second graph, the blue button and then the graph button. And we can go ahead on our notes and we can write this down. I always put my vertex in the middle. What happened? Let's see. Did you get it? Oh, I thought you said that something was wrong with it.
I was trying to tell you that the X is this one.
Got it. Okay, so I put my vertex in the middle because it helps me out, and I just do the ones that are above it. You can go as far as you want or little as you want, but I could put the 2 and the 1 here, and I could put the 4 and the 5 here. You're just kind of writing it out. You don't have to write the table out. If you want to go straight to your graph and do it, fine. I'm just trying to keep you organized, that's all. Okay, so this is a 5, this is a 2, which also means that's a 2 and a 5, because it reflects. Again, you can just copy exactly what this is. Basically, from here to here is what we just wrote down. Questions on that? Now that we have that, we can go to our graphing or our graph paper, and we can actually plot it out. So my vertex was at 3, 1, and then we had 4, 2, and then symmetrical, and then we had 5, 5, and then 1, 5, and go ahead and graph that out. Looks like that. And that's why I feel like it's super important that you kind of just check out the graph before you draw it, because just knowing that it's going to go up kind of just helps you visualize what's going on. Give me a second to make sure you got all that down. Oh, you made your graph like this. We were graphing it. Okay. me a second, make sure everyone's got it. Okay, here's what's super important. The axis of symmetry is probably one of the best things or the easiest things to know, but it can get a little tricky if you don't remember. Draw it in if you don't remember. The axis of symmetry is that line that cuts the graph right in the middle. So x equals what number? What x value cuts it in half? Yeah, 3. X equals 3. Very good. Good job. Okay, your x-intercepts. Basically, you're saying, where does it cross this x-axis? Does it cross at all? Does it cross this at all? No, so I have none. It's okay to write none. Sometimes there is none. Sometimes there's 2. Sometimes there's only 1. It just depends on your graph. Okay, your y-intercept. We can't really tell on here. But if you go back to your calculator really quick, there's 2 ways for you to do this. I'm going to show you both ways. You can choose which way you want to do it. It does not matter. Whenever you are trying to find your y-intercept, all you have to do is plug in 0. That's all you got to do. So if I plug in 0, I'm just going to show it to you by hand because that's just how I always want you guys to learn it, and then you can use your calculator later. Okay, minus 3, plug it in, squared, plus 1. All I did is I took 0 and I plugged it in.
Is that supposed to be a negative 3?
Minus 3. 0 minus 3. Like x minus 3 here. If you put a negative in your calculator, it might not work. Well, think about this. I have negative 3 squared. What's negative 3 squared? Close. If negative 3 times negative 3 is positive 9 plus 1? 10. Okay, so your y-intercept is going to be at 0, 10. I'm going to show you how to do that in your calculator now. If you go back to your table on your calculator, here we go, I'll show you. Take a look. 0, 10. So if you were right here on your calculator, you're like, what is the y-intercept? Just look for 0. Here it is. 0, 10. Look at you just confirmed it. Your math that you did in your head is going to be correct. Okay, or you can just type in your calculator too. You could just go to this. I'm going to show you so many ways that you just got to choose. Look at that. You could have, if you don't want to do your head, you don't want to use your head, you're like, too tired, you could just plug it in too. Either one. So if you want to try that too, you can do that and you'll also get 10. It just depends on who you are and what works best for you. Either one works. Okay, I know that we're moving slow, but don't worry, we're only going to do one more after this. Okay. Is it concave up or down? Very good. It's concave up. Hold on. There you go. Now, does it have a max or a min? Again, max, min is like, does it have a high or a low value? Very good. It's got a min. And where is it at? What is the lowest y value you see? Good. I hear it. 1. What is the domain of all parabolas? Yeah, all real numbers. Very good. Okay, your range always goes bottom to top. So from the bottom, I have nothing, I have nothing, I have nothing, and then I start. So I start at what number, and I go to where? Very good. 1 to infinity. Bless you. Do I include 1 in my graph? Do I put a bracket or parentheses? Bracket, good. So whoever, I don't know who's saying it, but good job. Okay, here's where my highlighters come in. So get ready for your catching skills. If you have them already, just have them out. Sorry, I'm like lightning speed sometimes. Jamil, boom. Ready? Boom. You got him back there? Here we go. Woo! That was my bad, I kind of threw too much. There, my bad. You got him back there? How about you? Whoops. My bad. There we go. Gotta work on my softball skills. Ugh. All right. So interval, did you get them back there? Sorry, I threw them too much. All right, interval of increase, I'm going to use yellow. So make sure you use the same yellow. And then the other one, I'm going to use a different color. Again, I just like to color code it because these are the 2 types that people always get wrong. If you get something wrong, it's most likely the interval of increase and decrease, and I don't want you to be scared of it anymore. I want you to actually get it. When I do this, I always label negative infinity and positive when I'm doing interval of increase and decrease. I look at the left side and I look at the right side. The left side will always be going towards negative, always. The right side will be always going towards positive because it's getting smaller, 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 bigger, 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 bigger. Okay, so on the left side of my graph, I don't care what order it's asking me to think, left side. And going towards negative. Am I increasing or decreasing from left to right? Yeah, decreasing, very good. So if I'm decreasing, I'm always gonna start at negative infinity. So negative infinity. And then where is my wall? It's like literally I have a boom. I have a wall. It just stops decreasing. Where is it at? Someone says 1. I understand why, because it's the y value. But I'm talking about the x value, and this is why we drew this in earlier. Yeah, 3. The wall, that dotted line I had you draw in is kind of like a wall. It stops decreasing at 3. Close it up. Wherever you stop is where you start. So I started at 3, and I go on forever to infinity. Again, I'm decreasing, decreasing, and then I hit a wall, and I stop decreasing, and it's at 3. Then I continue at that wall, and I go on forever up. Okay? All right. I want you to work on 6, either together or alone. When you're done, I will give you your homework. Okay? So we're going to have a good, 20 minutes to do your homework. I want to make sure that you're able to graph this. Okay? I want to make sure that you're able to graph it. I actually only want you guys to do, because I want you guys to take time for your homework. I want to give you 15 minutes for your homework to ask me questions. For that, I want you to do this one, and this one. And I want you to draw the graph. That's it. You don't have to do the rest. So do the transformations, the vertex, the axis of symmetry, and draw your graph. That's the only things so that means I move left, right, nothing. So you don't even have to write it down. Okay? But we did do something out front. The negative tells me that I'm going to reflect. And then, again, go in order. There is no H, so I don't write anything down, but there is a K, and a K is 4, and that just means up 4. And that's it. There's no H involved. And if there's no H, that means that our vertex is at 0, 4. So that was the only thing I saw, is people were putting right 1. But if it was right 1, I'll show you what that means, just so that you understand the difference. So if you're one of those people that wrote that down, x minus 1 squared plus 4. That would be right 1, right here, this minus 1. That would be right 1, it's not. Okay, so make sure that you're careful with that. And then your axis of symmetry was at x equals 0. Remember, that's coming from that part right here. Okay, so work on it. You have a long time. You have 10 minutes. So what I would do is at least get your graph on paper. So that when you walk out the door, you have it. I'm going to cross out one graph so that you can take your time and not rush through this homework assignment, because I think it's